Hey, welcome back for the second movie. This one is about decay reactions. And if you haven't watched the first movie, it doesn't really matter. The only thing you really need to know for this is the notation with the atomic number and the mass number. As you can see in the middle, the 7 3 lithium, this one. And it's the mass number and the atomic number and the elements that this 7 is always the mass number and this 3 is always the atomic number. And then we have the elements, the symbol of the element. And we will use BNAS for these decay reactions. But what is going on in an atom? Normally atoms are stable. That means that they don't do anything at all, at least the nucleus. The atoms can react with other atoms, that's part of chemistry, but physics is focusing on the nucleus or the center, the core, and the nucleus of an atom, most one are stable. It means that the ratio between neutrons and protons is good. And the neutrons are basically the glue. We have the strong force to glue them together. And yeah, too few neutrons and you don't have enough glue, too much neutrons, and you have too much glue and it becomes unstable. And if it becomes unstable, that ratio needs to become better. And there are two ways how that ratio can become better. One is with alpha decay. And with alpha decay, they simply split out, they kick away 2 protons and 2 neutrons. And it's called alpha decay, probably before because it was first discovered, because it's the first letter of the Greek alphabet. And alpha, this is an alpha, and it has two protons, so the atomic number is 2, and it has 2 protons and 2 neutrons, so the mass number is 4. This is alpha decay, the symbol and the numbers with the atomic number and the mass number. A different way is with beta decay. And with beta decay, then a beta particle or an electron is emitted, and that is formed because a neutron is changed into a proton and an electron is repelled. And so this is an electron, it has no mass, so the mass number is 0, and then it has a charge of -1, so that is why the atomic number is -1. And then it could also have extra energy, and it has extra energy, it emits a photon, only a very, very energy-rich photon. It's called gamma radiation. And a photon has no charge, it has no mass, so it's 0, 0. So these are the 3 types of radiation that comes from an atom. And we're simply going to make decay reactions. And with decay reactions, we start with one atom, the mother, and then that decays into a particle, one of these, or multiple, and then the other atom that is formed out of it, the daughter. So first up, explanation. So first up, I will do this with sulfur 35. So over here, S35. Okay, so first up, I always start with writing down the notation of the element I start with atomic number and mass number. And then it decays, so it is a reaction arrow. So I need to look up sulfur, the atomic number. So where are you? And I forgot, it is 35, so always searching for something with 35. Where's 35? 35 is over here, sulfur, and then it's 16. And 35, I can see over here, it says it has beta decay. Okay, that's fine, that's cool. So I know it is beta decay because it says in the last column, and I know its atomic number is 16. So, okay. 16? Yes, 16. 16, and we have beta decay. And I already explained that beta decay is 0 minus 1. That 0 minus 1, or the 0, 0, the 4, 2, is not in your BNAS. You simply need to know that by heart. And now we need to balance it, just like we balance reactions with chemistry, only we have two rows, the top row and the bottom row, and the top row is 35 equals 0 plus 35. And the bottom row, 16 equals minus 1 plus 17. And then we have an atomic number of 17. What is that? That is Cl, chlorine. And then our next example was chlorine 38. So 38, chlorine. Chlorine is 17 apparently. It decays because we need to make a decay reaction. And what decay do we have? Well, chlorine 38, it says beta and gamma. Gamma is always possible with another decay. So beta and gamma is possible. And you need to write down the beta and the gamma. So beta and the gamma. And now we need to balance it. So 38 is 0 plus 0 is 38. 17 is minus 1 plus 0 plus 18. And even though the author does not change because of the gamma, we still need to write down the gamma because it has some applications in the hospital. And then we have 18 is argon, one of the noble gases. Okay, next example is PO213. So 213 PO. And then we need to search for it. So I'm going to scroll down until I'm roughly at 200. And 13, there is, it's over here. And you can see PO is over here. So PO is 84. And it only is alpha. It's only alpha. So 84. And with a decay reaction, we have alpha. And alpha is 4,2. Well, if we have 4,2, we need to balance it again. We have 213 equals 4 plus 209, and 84 equals 2 plus 82, and 82 is PB, and that is lead. Okay, and then the last example, I'm going to put me a bit to the side, so kind of right over here. And that is Ra226. So we need to search for 226 Ra in the BNAS. Where are you? There are you. So Ra is 88 and 226 is alpha and gamma. Gamma can be there with the other one. So 86. And then we had alpha. Alpha was 4,2. And then we have gamma is 0, 0. And then we need to balance it. 226 equals 4 plus 0 plus 2, 2, 2. 86 equals 2 plus 0 plus 84. Oh, and 84 is PO apparently. We already used that over here. Okay, this is how we balance decay, make decay reactions, or how we do it. And I would like you to try it for yourself with these ones: beryllium 10, uranium 238, carbon 14, thorium 232, and cobalt 42, I forgot. And pause the video, try it for yourself, and I will write down what the correct answer is. So please pause, try to write down the decay reactions yourself. Okay, first up, beryllium 10. So we have 10B, E, and then we need to search it up in the BNAS. Where is it? Beryllium 10. 10 is all the way on the top. There it is. Beryllium is only beta decay, and beryllium has a 4. So beta. and then the top one is 10, and the bottom one is 5, and 5 is B, or, and then we have uranium 238. We need to search up uranium, so we need to go all the way down in the, so we have 230 something. Okay, we have 230 something over here. 238, wasn't it? Alpha and gamma. So we have alpha and gamma, and uranium is 92. Alpha is 42, gamma is 00, and then this will be 234 and 90. 90, what is 90? That is TH, thorium. Next up, C14. So C with a 14 and C is 6. The things you know by heart because you used it lots and lots of times. Where are we? C over here, C14. That's only beta. 0 minus 1, so we have 14, 7, and 7 is nitrogen. And then we have thorium 232. Thorium is 90. And we need to search up 1. Oh, 2, 4. Sorry. Thorium was over here. And which thorium was it again? 232, and that is alpha and gamma. So then we are left with 228 and 88, and 88 is RA, and last but certainly not least, K42. So on the search for 42 as mass number, oh, 40. 42, yeah, 42, there it is. Beta and gamma, and 19 as atomic number. Okay, and then the top one stays the same, the bottom one goes one up, and that is Ca. Okay, this is it. Don't forget to take a look in your planet, do the other questions as well.